Today we're going to take a look at our last derivative rule that we are going to study. There are other ones, but this is the last one we're going to study. This is called the rates of change or derivatives for product rules. Okay? So the one that we don't cover, that you might have covered if you've taken a calculus course before, is called a quotient rule. So just add a show of hands, who's seen the quotient rule before? Okay, a few of you have. If you absolutely love the quotient rule and you want to use it, you can do that, but I'm not going to teach it. This book does not heavily emphasize the quotient rule, and I'll show you what we do instead when we have quotients within the product rule, okay? And then you can choose. For those of you who know it, that's fine. If you don't want to do it, then this will work. Got it? Okay, so to start with, what is the product rule? The product rule says that if we have a function that's two functions multiplied, so f of x times g of x, we cannot do the derivative of f of x times the derivative of g of x. It will not give us the right answer. In my traditional calculus course, I do an example that shows exactly why it fails. And it's pretty quick. I didn't think to do it in this lesson, but it won't work. So what do? We actually take the original function of one of the two pieces and multiply it by the derivative of the other piece, and then add it to the reverse of that. Now, the notation that I use and the way that I always teach it is backwards from many books. I'll explain why I do that. But if you reverse these two and you do these in the other order, it's totally fine. Because addition is commutative, right? 5 plus 3 is the same as 3 plus 5. So if you've already learned this some other direction and you switch them around, no problem. Okay? The other thing is that multiplication is commutative. 3 times 5 is 5 times 3. So the other thing that you could switch in this notation is you could actually switch these pieces, right? You could write down g prime and then f, just like f and then g prime. So the order of these is really not so very important. It's not important at all, as long as you have all the components there. The reason that I like to do this in the order that I do it is because no matter how difficult the problem looks, you can always start it, because the very first thing you do is just rewrite the first piece. And for some students, just getting started on a problem is enough to be able to continue the problem. And that's why I like to teach it this way. So let me show you an example of what I mean. Here's our first problem. Now on this one, you really could just multiply this all out and use simple rules, correct? Yeah. You could do that. Now that's not true for every problem we're going to do today, but on this one you could do that. So I'm going to show you how to use the product rule with this though, which makes it easier. Okay, so we're taking the derivative. The first thing we do is we take the first piece and we just rewrite it. So no matter what happens, we can start the process. The second piece we're going to look at, and we're going to take its derivative. So piece by piece, what is the derivative of 32x cubed? Somebody said the number. 96, yep. 96x squared, and then the derivative of the 49 is 0. So this is it. Then we're going to add, and we're going to do this in the opposite order. Now we're looking back at this piece, and we're taking its derivative. So what's the derivative of 3x squared?
6x.
Good. And 15x?
15.
And then 1? 7, sorry, 7? Yeah, 0. So that's the derivative of the first piece. And then we end the problem much like we started, with rewriting a portion of the problem. We rewrite the 32x cubed plus 49. And because of the way that your book presents this, there's no requirement that you ever simplify that. There will be one component once we get into the next chapter where we will see some simplification for a different purpose, but there's never going to be a point in the problems we're working with now that says, now clean this all up. Okay? So the problem's over. You're done. It's all good? Okay. So as with most mathematics things, we start with something that's pretty straightforward and they get a little bit more complicated as you go, right? All right, so taking a look at this one, you'll notice that one piece of it is much like what we just did. It's a polynomial. But the other piece is a different rule. It's an exponential. So when we do this piece, we're going to have more rules going on within the derivatives themselves. Okay, the problem starts out same as before, f prime of x. And what's the first thing we do? Rewrite the first piece. 4x squared plus 5x minus 6. All right, now looking at this second piece, we're taking its derivative. All right, so we've got an exponential. How do we take derivatives when we have exponentials? Let's start with this. What happens to the 3? It stays because it's a constant multiplier, right? Okay, so I'm just going to write down the 3. What's the derivative of 4.2 raised to the power x? Perfect. 4.2 raised to the x. You can put those parentheses around the 4.2 or around the 4.2 raised to the x, doesn't matter to me. And then times the natural log of 4.2. One thing you do need to be careful is that that x looks like an exponent. Do you guys get me? Sometimes when we're writing quickly, x's location might look like all of a sudden it's 4.2 times x. So do be careful that if it's an exponent is x, that the exponent, so that the exponent really looks like it's an exponent. All right, we're doing addition. These are all addition problems, right? Always addition between them, and we're doing the reverse. Now I need the derivative of 4x squared plus 5x minus 6. So what's that one?
8x.
Perfect. And last step, rewrite the second piece. 3 times 4.2 to the x. Okay, so it wasn't way more difficult, right?
I thought the x was on the outside.
It doesn't matter. Either way is fine. It means the same thing. Yeah, so you could write it like that, or you could write like this. Have the same meaning at the end there. Okay. The only thing that made that more difficult is that you're doing multiple different rules for derivatives in the middle of the process. What's going to make this one more difficult? Ooh, you saw it, didn't you? Kendra said there's a chain rule. Does everybody see where the chain rule is?
Semi.
What's that?
What's the chain rule?
What's the chain rule? The chain rule is the one we did last time with the insides and outsides. Does everybody see something that's inside of something else? I mean, there's definitely multiplication here. We got a product rule, but there's also a chain rule involved. So this piece right here, when I go to take its derivative, I'm going to have to use the chain rule when I'm taking its derivative. Not only is that going to make the process a little bit more difficult, it's also going to make the answer look longer because there's going to be more components. Okay, that doesn't hinder how we start though. We start the exact same way. We rewrite the first piece, 9x cubed plus 7x to the fourth. That part's the same. And then I need the derivative of 14x squared plus 6. What's that? 28x, that's right. Okay, now we're ready for the chain rule part, the part that's the more long or difficult part. I need the derivative of 9x cubed plus 7x to the fourth. Now here's your chance to show off what you remember from doing your chain rule last time. How do you take the derivative of that component? Pull the 3 down, or 4 down, thank you. Okay, we're going to write 9x cubed plus 7x to the third. So that's the derivative of the outside part. What's next? Then we take the derivative of the inside. Hannah wasn't even here last time. Very good. Okay, so what's 9x cubed plus 7x? 27x squared plus 7. You know, all the ladies are giving me some great answers over here. I'm not hearing a lot from the boys today. You guys better step up.
And the room is divided.
Man, it is a very divided room. Maybe I should move to either side of the room and they'll talk to me, do you think? It might work. We're going to give it a try. Okay, are we done? No, what's missing?
No, absolutely not. You have to rewrite the last part.
Thank you so much, Caleb. That's exactly right. He's not to be outdone by the ladies. All right, 14x squared. What do I have? Plus 6. Okay. It is common in the middle of a problem where there's a chain rule and a product rule for you to forget that last piece. that part where we just rewrote it, be careful, okay? Because honestly, that's where I see mistakes made on the gateway exam as well. Is that, man, you just feel like you've been writing the whole problem forever, and you just forget the last part of it because it's already so long. So pay attention to what you're doing. Okay, so here's our third one. How about this one? There are two chain rules. That's exactly right. So this one's going to be even longer when we write it out than the last one. All right, so I've got the derivative. Where do I start? Not yet. First, we need to take the regular part and rewrite it. We'll get to that part, though, in a minute. So we have 49x squared plus 2 to the negative third. Okay, so just rewrite the first piece. The second piece we'll take its derivative of. So I need the derivative of 4.6x plus 4 to the 2 power, or squared. Pull the 2 down, right? We're going to put a dot right there to indicate multiplication, or you can use parentheses. You can put to the power 1 if you want, or you can leave it off, obviously. And then what's the derivative of 4.6x plus 4? 4.6. Okay, plus. Don't forget the plus. Now we're going to do it in reverse. So Matthew, you were trying to tell me the derivative of the first part earlier, so let's do that part now. What do you have? Okay, so I'm going to put the negative 3 in parentheses, and then what? What's that?
I don't know.
Okay, that's all right. Somebody help Matthew out. What would you do next after you've brought the negative 3 down? Rewrite the inside first. So we're going to do the 49x squared plus 2, and then we'll do the negative fourth, and then we'll do what the other part you were wanting to do. So what is 49 times 2? 98. 98 what? X. And it feels like we've been writing forever, but we're still not done. What's missing? Yeah. So let's see if I can squeeze it in here. 4.6x plus 4 squared. Barely. It's barely there. Very, very long. Okay, any questions on that one? Yes, Lainey?
Is it wrong because I keep forgetting like which one you write out first and which one you solve first?
No, you can flip the order. It's fine. It doesn't hurt at all. So I will always do in the same order just because not everybody will see it the same way. And so just for the sake of consistency, I'll keep going that way. But if you switched, it's okay. Okay, so here is one that does not look like a product. I mean, it kind of looks like a product on top, but it really isn't. The top just has one variable in it. If you just had the numerator, you wouldn't need a product rule because there's only one variable. But there is a variable in the denominator, right? And we do have a denominator. So I told you we don't really need the quotient rule. This is the point where if you've learned the quotient rule and you like it, you can use it, but you don't really need it. So let me show you what you can do if you don't have and don't know the quotient rule. All I'm going to do is I'm going to rewrite this problem, 12.624 times 14.831 to the x. And I'm going to take everything that's in the denominator, I'm going to move it up to the numerator. So I've got x squared plus 1, which we kind of did this last time. But if I just move things up, what do I have to do to compensate for that? Yep, I need a negative 1 exponent. And now, it's product rule, right? So I have two pieces. The first piece is this one. And the second piece is this one. So we can do the product rule. F prime of x, and we rewrite the first piece. So 12.624 times 14.831 to the x. And now I'm going to take the derivative of x squared plus 1 to the negative 1 power. What do I have to do? Chain rule. Very good. And the chain rule says I'm going to bring that negative 1 down. Now, please be careful when you bring that negative 1 down and put that negative 1 in parentheses. Because what would it mean if you leave the parentheses off? It would be subtraction. And that happens on gateways too, is that I have to mark things wrong because of parentheses that are missing, because it means something different. We don't want to do that. All right, so I've brought the -1 down. What do I do to the inside? I leave it. I rewrite it, x squared plus 1. What will the new power be? -2. And then I need the derivative of the inside, which is 2x. Very good. All right, I'm just going to move on down here and put a plus sign here. Okay, so it's going to continue going, so I'm not going to go all the way across my screen. Now I need to do it in reverse. I need the derivative of the 12.624 times 14.831 to the x. It's an exponential, right? Coefficient at the beginning stays. I don't have to do anything with it but rewrite it, 12.624. What's the derivative of 14.831 to the x? Okay, does everybody remember that one? Okay, good. And then what's missing? Do you have a question first?
Would it be wrong if you put the 14.831 in like parentheses?
You mean like after the natural log?
Yeah.
No, that's fine. You can do that. Your calculator makes you do that usually. Most calculators do anyway. They'll put it in parentheses automatically. I try, because there's so many parentheses already, to not write them when they're not absolutely necessary, but definitely don't want to leave them off when they are. So it's kind of at a delicate balance. What else do I need? The second part, rewritten, right? Which is x squared plus 1 to the -1. All right. This is the messiest one, I think. I don't think the next one's as messy. Nope, this one's definitely the messiest one that we're going to do. The thing about this one that makes it tricky is that that second piece, 39 over 1 plus 15e to the -9.96x, is a logistic function, right? And do you remember last class period when we did logistic functions that it's a chain rule inside of a chain rule? And that's what makes this messy. Okay, so the first piece though is not a chain rule at all, so that part's helpful that at least we don't have that as well. So this piece stays put. I'm just rewriting right now. I'm going to bring my 39 up or out, and then I've got the 1 plus 15e to the -0.96x all raised to the -1. Now the 39 is not raised to the -1 because it was in the numerator to start with, right? That doesn't change. There are definitely still two functions here. We have one piece here, and we have our second piece here to deal with. Okay, so our derivative rewrites our first piece. You can always start the problem. Now we need the derivative of 39 times 1 plus 15e to the -0.96x to the -1. So the first thing is to take the -1 exponent and bring it down. That makes this -39 in parentheses so that it doesn't inadvertently look like subtraction. We're going to rewrite the inside because we always rewrite the inside on a chain rule. 1 plus 15e to the -0.96x, that's the inside, to the power -2. Now looking inside of this, we need the derivative of the inside. We need the derivative of the 1 plus 15e to a power. So the 1 plus goes away, right? And it's just the derivative of e to a power. And what's the derivative of e to a power? Same thing, yeah. So I have the 15 still because it's a coefficient multiplier, e to the power. But in doing that, you even realize as you're writing it that the power itself is another function, right? Because it's not just x. So what's the derivative of the power itself, the -0.96x? -0.96. Again, in parentheses so that it doesn't end up looking like subtraction. And that's half the problem. But it's the harder half of the problem. Okay? So I'm going to do an addition sign. The other half of the problem is to take the derivative of 8x squared plus 13. Thank you. Lainey's not going to leave me hanging over here. All the boys are just staring at me. 16x. And then what do I do? Yeah, I just rewrite the other part. 39, and then 1 plus 15 e to the negative 0.96 to the negative 1.
Would it be wrong if you left it as a fraction for that part?
No, you could leave it as a fraction. That would be fine. Doesn't hurt anything at all. Okay, so that's F. Oh, there's actually 2 more after this, aren't there? We went to H today, I think. Okay, this one has a natural log part of it too. It's still a product rule. We've got 2 pieces, here and here. So what is the first step? Rewrite the first part, e to the 4.7x squared. Now I need the derivative of natural log 49x squared. So what's the derivative of natural log of stuff? 1 over x. So I'm going to have 1 over 49x squared, because it's 1 over the inside of the log, whatever it is. But then the inside of the log is not just plain old x on this one, it's an inside function. Chain rule, right? So what's the derivative of 49x squared? 98x. I think we saw that one earlier, actually. And we're half done. We might even be able to fit it all in one line this time. Now I need the derivative of e to the 4.7x squared. So derivative of e to a power is same thing. This is e to the 4.7x squared. And then I need the derivative of the 4.7x squared, which would be, what is that? 9.4x, that's right. And then I rewrite the other piece, natural log 49x squared. See, that one's not as bad as the last one, right? They both had chain rules, actually, but they're very brief. They're brief rules. Here's our last one. Last example, anyway. All right. We rewrite our first piece, 4 minus 7 natural log 9x. What's the derivative of 8 plus 6 natural log 2x? Well, the 8 plus stays, right? I mean, not stays, goes away, right? Okay, so I don't have to really think about him. What am I going to do with the 6? I can either put it on top of the fraction or put it in front of the fraction, either way. And then what's going to happen with the natural log 2x? 2x in the bottom, or on the bottom, right? And then I need the derivative of the inside, which is the 2x. Come on in, we've got one example where we're finishing up. What's the derivative of the 2x? 2, you got it. Okay, so this is half done. Now we're going to do the other half, which looks an awful lot like the half we already did. What's the derivative of 4 minus 7 natural log 9x? Oh, don't forget the negative, good. Negative 7 over the 9x times 9, thank you. That's my derivative part, and then the other part we simply get to rewrite. 8 plus 6 natural log 2x, and we're done. There are, towards the end of this assignment, some application problems that go back into the business concept, so I want to remind you of what it would mean for you to have an average cost, an average revenue, an average profit. Think about what happens when you were to find your average homework grade. Okay, I don't know how many we have at this point, like 12. Let's say 12 for the sake of argument. You've got 12 homework grades. And you've got them all listed. What would you do if you had to find your homework average and you didn't have Jupyter? You'd add them all together and then divide by how many grades you had, okay? So when you're looking at the average of a cost, profit, or revenue, you're going to find the total cost, just like finding your total amount of homework points. And you're going to divide it by however many items it is that compile that total. So in a business sense, that's usually the number of items that you've sold or manufactured or something like that, okay? So keep in mind when it talks about an average, that's what it's looking at. Make sense? All right.